on, guys? It is Hump Day. It's Wednesday, March 18th. Check out my not mathematically correct. How are you? Joke. I hate negative numbers and will stop at nothing to avoid them. It's just a bad joke because nothing and zero are not the same thing in math. Nothing implies an empty set, a set with no members, whereas zero is actually a real number. And although in real life we would say nothing and zero are the same thing, mathematically they are considered different. All right? Who cares? I just killed that dad joke, didn't I? All right, so it is Wednesday. We are really to the last topic in this particular unit on triangle similarity. We are not going to do the proofs that follow this, so you'll be happy to know that, especially if you look those over and see how long some of those are. But I am going to also take this lesson on similarity and break this up into 2 days. Okay, so we got to start out with a little graphic organizer here on similarity. Unlike proving congruency, there really are only 3 ways to prove that 2 triangles are similar. All right. The first technique is angle-angle similarity. And you might go, why do we not say angle-angle-angle? Why is it not 3 A's there? Well, it's because if 2 of the angles are congruent in 2 corresponding figures, or 2 corresponding pairs of angles are congruent, then automatically the third ones would have to be congruent. For instance, if you had a 30, 60, 90 triangle, and you had another triangle that we're trying to determine if they are similar, well, if the other one has a 90 and a 60, well, then automatically the third one would have to be 30 as well. So here's simply what angle-angle similarity says. It says if 2 corresponding angles are congruent, then the triangles are similar. So angle-angle similarity is a proof or a shortcut to prove that 2 particular triangles or quadrilaterals or any polygon are congruent. So we got a couple of examples underneath here. Look at this. It says determine if the examples below are similar by angle-angle similarity. If yes, write a similarity statement. So check it out. In number 1, notice angle A and angle D both have the same measure. Angle C and angle F have the same measure. So guess what? We already know angle B and E are going to be congruent. So obviously this would be a yes. These are similar to each other. And so my similarity statement would be triangle, I'm going to call it triangle ABC, is similar to triangle, and I want to get this in the same order. So my 75-degree angle needs to be first, then the angle that I've not marked, E, second, and then my 31-degree angles are last. So triangle DEF. Check out number 2. Number 2, we have just 1 pair of angles as marked as being congruent, but right here, our good old vertical angle friends, we know that those 2 are also congruent. So this is also a yes. These 2 triangles are similar. All right, so there's my similarity. I'm going to say triangle something, something, something is similar to triangle something, something, something. So I'm going to start with the big one right here. I'm going to call this triangle VXW. All right, VXW. So I'm going with the 1 tick mark, the 2 tick marks, and then angle W didn't have one. So over here, let's do it the same way. Triangle YXZ. So there's a similarity statement that's written correctly because I've got the congruent angles in the same positions. All right. So let's move forward a page or 2, all right, and actually do a problem or 2 with that, okay? These are angle-angle, all right? So 1 through 6, these should all be angle-angle, but it's possible that they're not similar. So let's give some of these a try. So these will be kind of our practice problems right here. So determine whether these are similar by angle-angle, and if so, write a similarity statement. So we know that these 2 angles in the middle are vertical angles and therefore congruent, but we also have a couple of parallel sides, and those 2 parallel sides are cut by 2 transversals. CG is a transversal and DF is a transversal. So we have really two pairs of alternate interior angles. Let's use this one, angle D, 2 tick marks, angle F, alternate. They're on either side of the transversal, and they're both in between my two parallel sides. So that's all it takes. I don't even have to mark angle C and G as being congruent. So this would be a yes, okay? And so triangle, let's call it CDE, is similar to triangle GFE as well. See how we're percolating there? It's pretty easy, isn't it? All right, 2 is the little triangle similar to the entire triangle? Well, again, we've got some parallel segments. So they are cut by 2 different transversals right here. So we don't have alternate interior, but we do have a pair of corresponding angles. So those are corresponding angles, okay? So angle, we're going to call it angle Q and angle M, all right? But this side is also producing a couple of corresponding angles. So those 2 are corresponding angles as well. So this is definitely a yes as well. And so my my similarity statement, how about this? QLP is similar to triangle MLN. So again, important how you write that. You got your choice. You can write it 6 different ways because these 3 letters can be arranged in 6 different orders. But once you write this one, you're bound to write the second one in the same way. So I chose the Q here, had 1 tick mark, L, which doesn't have any, and then P, so I went QLP. So then I got to go MLN for the second one. All right, 3. All right, this time we've got a couple of angles marked. Well, check it out. Angle Y and angle C are both congruent because they're both right angles. But then we've got 2 different angles, 39 and 51. So what we should do here is realize that angle S, we need to figure out what angle S and what angle H are, okay? So angle S is going to be, if I add 90 and 39 and subtract from 180, or if I just say 90 minus 39, okay, that's going to be 51. So angle S is 51 degrees. So check it out. If angle S is 51, it is a corresponding angle with angle W, which means that angle H should also be 39 degrees. So this is also a yes. And so let's just get our similarity statement written correctly. All right, so let's go small to big angle. This is going to be ESY. So angle ESY is going to be similar to, triangle ESY is similar to triangle HWC. Number 4, check these out. I've got 68 and 54. If you add those together and subtract from 180, this angle at the top would be 58. All right, and guess what? We already see that these are not going to work. This is a 49 degree angle. So these, we say, are not similar. They are not similar, because they have to have 3 pairs of congruent angles. 5. We have a 25 degree angle here. We got a 91 and a 67. So let's see if we can figure these out. And remember, that 67 is also the angle. This big triangle has that same angle. So let's figure out what these others are. If you add 91 and 67 together and subtract from 180, that's going to give you 22 right there. Then if I take 25 and 67, that's going to be 80, 92. 92, so this angle up here is going to be 88. So check it out. We do not have, they do have the 67 degree angle in common, but check it out, 25 and 22 degrees. Those are not the same. Those would have to be, the same angles, and 88 and 91 are not the same. So here's another pair of triangles that are not similar to each other. 6 The bow tie problems, I call these bow tie problems because the shape kind of looks like a bow tie. We know that these two angles are going to be congruent because they're vertical angles, and we've already got another matching pair. So yes, my angle similarity, these two triangles are similar to each other. So triangle, let's go PQX, okay? And that over here would be ZYX, PQX and ZYX. Pretty easy, pretty easy. All right, let's tackle one more method right here, side-side-side similarity. So side-side-side is not only a method of proving congruence, but notice, by the way, notice these have a little similarity symbol so that you don't confuse side-side-side congruency with similarity. So this is side-side similarity. And remember, the sides are not congruent. Check this out. If all corresponding sides are proportional, then the triangles are similar to each other. So again, this one does not even consider the angles. It just looks at the sides to see if they are in fact proportional to one another. So let's take these two examples right here and see if that is the case. All right, so we got two triangles right here. So let's see if we can come up with some proportional sides and see if they are equal to each other. Okay. So if you look at these two triangles, all right. So let's see, just the way they're drawn. Let's compare 3 and 6. Let's compare 4 and 8, and let's compare 5 and 10. And guess what? Every one of those fractions are equal to each other. All of them are 1/2, aren't they? So this would definitely be a yes. And let's write, if we can squeeze our similarity statement in, triangle QPR is similar to triangle TSU. So those two would be similar. So again, you're taking the corresponding sides and you're comparing the ratio that's formed when you compare those sides. All right, look at number 4. We'll move this up just a little bit, okay? All right, these two triangles appear to be drawn in some kind of oriented in the same direction. So we would assume that 30 and 24 are corresponding sides, and 32 and 25, and finally 35 and 28, okay? So if you took your calculator, or if you just reduce these on your own, if you reduce these fractions, 30 over 24 is going to reduce to 6 goes into both of them. This is going to be 5/4. Well, 32 over 25 won't reduce, and neither will 35 over 28. So we would say these are not equal to each other. Therefore, these are not similar. Since the sides are not proportional, it is not, those two triangles are not similar. So let's go to the next page and we'll take a look at the side-side-side similarity examples. So there's 2 here, and I think there'll be 4 on the next page. So determine whether these triangles are similar by side-side-side similarity. And if yes, write a similarity statement. All right, so here again, you notice this time you've got a couple of decimal values for the sides. Don't let that freak you out. All right, we got 9 over. Okay, so check this out. The obtuse angles are not in the same position, are they? So really think about spinning this triangle around. So side NK would really be proportional to side ED. All right, those two would be corresponding. Those would be the corresponding sides. So you have your big obtuse angle up here and your big obtuse angle down here. So remember, the angles can be, those would be the corresponding angles. So we want to compare 9 to 14, okay? And again, those two also are the shortest sides. So if you do short side to short side. The next longer side would be NR, that's 13.5 over 21. and then take the two longest sides, 20.25 over 31.5. So I probably should have mentioned that where could I, on the previous page there. If you just compare size, if you look at these, smallest number should be a corresponding one with the smallest number here. Next largest, biggest, okay? All right, so if you check these out, believe it or not, believe it or no, all three of these, I'm gonna grab a calculator instead of pulling up a calculator. If you do 9 divided by 14, you're gonna get 0.642857143, gonna be a long decimal number. Guess what? If you divide 13.5 by 21, you're gonna get the same number. So all of these are equal to each other. So this is a yes, okay? All right, so I'm gonna put a little note here. Use a calculator to determine if these fractions are indeed equal to each other. You say, well, how many of them will it take to make it not? If just one fraction is not equal to the same thing. So all three of these are, so these two triangles are similar to each other. So triangle, I'm gonna call it KNR, is similar to triangle DES. 8 is the big triangle, the whole thing, and this smaller one, the smaller triangle, are those two proportional? All right, well, let's see. If they are, we can start with the smallest side. So 15, 20, and 30, the three small sides there. So we would want to go 15 over 20. Does that equal, now here is where people goof this up. They want to say 6 over 8, but you got to remember, you got to take that whole top side. So this whole top side is 21, okay? So is, and I started that totally wrong. Let me back up just a minute. I don't even know why I don't have that on full screen. So let's try fixing that up here. We don't want to say 15 over 20. I could probably make that work, but let's compare small triangle to big triangle and keep it consistent. Okay, so let's try it like this. We're going to say 15 is the top side of little triangle WXV. All right, and then 15 plus 6, 21, would be the whole distance, okay? So is 15 over 21 equal to 20 over what this whole side is, which is 28, okay? And is that equal to 30 over 42? Are all of those equal to the same thing? Well, let's take a look and see. 15 over 21, 3 goes into both of those. That's going to reduce, this is going to reduce to, I'm sorry, not 3, 5 divided by 3, 5 over 7. That's going to be 5 over 7. 20 over 28. So 4 goes into both of those. 20 divided by 4 is 5. 28 divided by 4 is 7. And check it out. 6 goes into both of these. So 30 divided by 6 is 5. 42 divided by 6 is 7. Bingo, lingo. They're all 3 equal to 5 sevenths. Now, could you have just plugged in 15 over 21, 20 over 28, and 30 divided by 40? Have you done the divisions for those? Sure. If you want to use your calculator, just divide those. Reducing is not your bag. Then do that. Reduce them in the calculator. So this would be a yes. So triangle, let's take the little guy, WXV, should be similar to the big triangle, which is WUY. WUY. All right, on the next page, we got 4 more here. So we're checking these to see. What I'd like for you to do is turn the video off for just a second, or hit pause, and try number 9 yourself. Okay, try number 9 yourself and see if you get these to be the same. Okay, so just pause it now for a second. Okay, so you're back. I had to pretend that I was pausing. Did you notice that? All right, so I'm going to start with small side compared to small side. It doesn't matter if you go, if you put the 4 on top or the 5 on top. I'm going to say 4 over 5 because those are the two smallest numbers in each triangle. All right, I'm going to take the medium-sized numbers. All right, this is like Goldilocks, right? All right, so let's take the two next size numbers. Since I started with 4, I should put 7 here, okay, and 12 here, and then 10 and 16. So are these fractions, in fact, equal to each other? Is 4/5 equal to 7/12? Well, no, they're not, right? These are not equal to each other. None of these fractions, can come out to be the same thing. Again, if I grab a calculator and show you this, 4/5 is 0.8. 7 divided by 12 is this one is 0.58, and this one, 10 divided by 16, is 0.625. So none of these are equal to each other, okay? Remember though, it only takes one of those. So if you end up with two ratios that are the same, that is not enough, because remember, this is side, side, side similarity. So these are not similar. Okay? All right, I hope you figured that out before you turn the video back on. We'll see, right? All right, number 10. So here we go. We're testing this, plugging these values in. So I think it's best to go from small to large, all right? So in the little triangle here, 5 is the smallest side. In the bigger triangle, 18. In the next triangle, then it'd be 12 over 43.2. And then largest side, 15. And that is over 54. Okay? Believe it or not, all 3 of these fractions are the same value. So you say, what value are they? 5 divided by 18 is 0.2777. Test the others out. 12 divided by 43.2 is 0.27777. 15 divided by 54, 0.2777. All right, so these two triangles are similar by side, side, side similarity. So this is a yes. So triangle, I'm going to go RPA. All right, it should be similar to triangle RYT. And there you go. All right, 11. We only have 2 sides to compare this time, don't we? Okay, but these are right triangles. So we definitely need to test these other sides that are not given to us. So how do we do that? Well, this is as good a time as any to introduce the Pythagorean theorem, or reintroduce you to that, the Pythagorean theorem. Remember the Pythagorean theorem from Algebra 1? All right, if a triangle is labeled with sides A, B, and C, where C is the hypotenuse, well, then this relationship is true. The sum of the squares of the 2 legs is equal to the square of the hypotenuse. So A squared plus B squared equals C squared. So if you'll notice over here, we have one of the legs is 5, and we would actually refer to this as the short leg. Short leg is 5, and the hypotenuse is 13. So we need to find this other side. So plugging 5 in for A and 13 in for C, we have 5 squared plus B squared equals 13 squared. So B squared is going to be 169, that's 13 squared, minus 25. Guess what? B squared is 144. Well, if B squared is 144, then that makes B 12. So this side is 12. All right. On the second triangle, we can do 9. Let's move right over here and do this one. All right. 9 squared plus 21.6 squared equals the hypotenuse, which is what we don't know. We'll call that C squared. So 9 squared is 81. 21.6 squared. 21.6 squared. Yeah, I know that right off the top of my head, right? That is 466.56. 466.56. That equals C squared. So if I add 81 to that, That's going to be 547.56. There's c squared. And if I then take the square root of that, okay, let's go up and, oh, crud. All right, let's try that again. Second square root of 547.56. Well, guess what? That is 23.4. 23.4. So there's that side, all right? So this one just makes you do a little work before you start. So here we go, let's test these proportions, see if they're equal to each other. We'll start with the small sides. 5 over 9, 12 over 21.6, and 13 over 23.4. So I want to check out all three of these, and they're all, they are going to all be the same. Let's do what it is. 5 divided by 9. Oh, this is going to be 0.55 repeating, okay? So all of these equal 0.555 and so on, okay? 0.5 repeating, I guess we could say, right? So since all three sides are proportional, these two triangles are similar. So triangle, let's go with small to large angle. So x, z, y is similar to triangle v, r, w. Bingo, lingo, done. 12, last one, all right? So we've got this little small triangle, and we're talking about then the entire triangle. So again, you want to make sure you're using the entire sides right here, okay? Okay, so let's start with 6. So we would go 6 over 16, because we're saying this side compared to this entire side. So 6 over 16. And then we would say 8 over, well, this would be this whole side. So this whole side is 12 plus 8, which is 20. So 8 over 20. And then the third one is 9 over 24. Those are corresponding sides. So you got to make sure you got corresponding sides in these ratios. Well, if we just reduce the first two, I guess we could reduce all three of these and prove it. Let's do that. 6 over 16, this is going to be 3/8. All right. 8 over 20, that's going to be 2/5. And see, we're done right there. We know this is not going to be true. And then the last one, that's going to be 3/8. So, hey, two of them did equal 3/8, right? But guess what? 3/8 does not equal 2/5 from either side. So these dudes are not similar by side. Okay? All right. So I am going to go back a page. All right. Go back another page. Here we go. Tomorrow we will tackle side angle side similarity. All right. We'll do those two examples. We'll come over a couple of pages. We've got some side angle side similarity problems right there. And then here are some practice problems. I'll throw some answers here in for these. And these are all mixed up, okay? So we'll do a few of these tomorrow in the next video. And then this will be the homework that will be due Thursday, okay? This homework will be due on Thursday. So you say, well, what is due today? Well, here's what's due today. Send me a picture, all right? Go back here, all right? So this page, which is 125. So you're going to Wednesday homework. There are pictures of the notes on pages 125 through 127, okay? That's all you got to do. It shows me you listen to the videos. No, it doesn't really. I mean, I guess you could just fast forward, get to the end of the page, and write down if you wanted to. But I hope you listened to that because you probably needed the instruction there along with it. All right? All right, so we're shutting her down. That is it for Wednesday. Hope you have a good hump day. We'll see you tomorrow.